So, yesterday we had a very nice introduction to SQL and we understood what an SQL is and why SQL is needed, right? Okay. Now, today we want to deep dive into. I just ended yesterday's session by just writing these names like RDMS. We talked about SQL, but now I want to switch my gears and we want to now take our understanding to the next level. Okay. You might have seen the name of this session. It says OLTP, OLEP. So today we are going to understand all the important concepts around the databases and the data warehouses. Okay. Okay. Anyone has any question before we start, or shall we start? Do we have the green
Yeah,
signal?
Vipul.
Yeah,
So,
yes, Arjun.
I have some questions in regards
Mm-hmm.
to the Snowflake. So,
Okay.
let's say, earlier,
Mm-hmm.
Snowflake has been treated as a data warehousing thing only.
Agree. Only
But
a data
now,
warehouse.
as the Snowpark has introduced,
Right.
so with the help of Snowflake also we can do the data engineering, right? Because earlier the
Yes.
ETL process was not happening in Snowflake.
So there were many limitations out there. So we were not able to. I mean, there were a lot of features in Snowflake Data Warehouse, but most of the projects which I have also seen in my organization, they were around like we were just storing data for analytics purposes, right? So that was one thing which everyone was missing. And Snowpark was introduced long back, few years back, but now it is gaining attraction because, yeah, of course, using Snowpark, we can build data pipelines, right? We can do a lot of things. We can now do process the different types of data. We can run Python on Snowflake Data Warehouse. So yes, so now what? So let's say if you have a shop nearby, right? And that shop
Hmm.
is dedicated to sell some specific type of only one type of product, right? So and then you have 10 shops, right? And then whenever you have to go out, you have to buy, let's say, five things, then you have to go five different shops, right? So this was the scenario previously when we started developing the data pipelines, right? So what companies used to do, they had to so I'll open this page as well. Okay. So at that time, people or the corporates have to go to multiple vendors. So they had to pick and choose multiple softwares for that. So first of all, they will say, okay, I need a language to develop my application. Which language should I go with? Should I go with Java? Should I go with Python? Should I go with Scala? Or I mean, ROR, Ruby on Rails is also there. And then they had to decide which database you should use at the backend, whether they should go with Oracle, Snowflake, not yeah, Snowflake Data Warehouse can also be a database now. So whether we should go MS SQL, MySQL, so there were a plenty of different options available. And then we had the data warehouse option, where do we actually store the data for the processing and for the reporting purposes. So again, we had multiple tools for that, and then finally we have one place. I mean, now we wanted to do the reporting. So for reporting again, there are a lot of different tools. So now let's say for one thing you have to use one specific type of tool, and then if you want to kind of then you have to spend extra time in the integration as well. First of all, you will have to decide based on your budget, based on the expertise, based on the skill set your company has, and then based on that you will have to decide some set of tools, and then you will have to integrate them so that you can create a very nicely defined data pipeline, right? So this was what happened. So now think that there is a shop where you can buy all the different things. What you will do? So this is the scenario with the Snowflake database right now. You can ingest data, you can transform your data, you can manipulate your data, you can run ADAs, you can also do data science, you can also do your AI. So all these things can be done in one place, right? So that is why the things are getting exciting at the Snowflake data warehouse. And one more thing is there is that Snowflake data warehouse is also very good with the security, right? So why not bring everything in one place? So that is why you might see that there are projects where companies are migrating from Spark to Snowpark, right? So and one more great thing is that everything is managed for you. You just have to pay for what you use, and the other benefit of cloud computing, right? So this way, you are just not taking the full advantage of the the cloud architecture, but at the same time, you are having everything under one roof. Do you agree?
Yeah, understood, Vipul. So,
Yeah.
so here, like as you have mentioned, that we can also build the pipeline through
Yes.
Snowflake as well.
Yes.
So, in this course, like, are we taking Snowflake as a data warehousing or the end-to-end thing?
Everything, everything. So all the aspects which we have in Snowflake data warehouse. So we should. So let's say if tomorrow you get in, you are working in Snowflake data warehouse, and tomorrow you are asked to work on Snowpark, you should be able to scale up as well. So you should know all the different things which we can do in Snowflake data warehouse. So that is why we are not just taking data warehouse as a data warehouse. We are also doing Snowpark, so that we can understand what are the different capabilities Snowflake offers. So for tomorrow, if you have to work on any migration projects, for example, you will have to create your Spark pipelines in the Snowflake data warehouse, then you will be able to do that as well,
Okay,
right?
got
So
it.
we will go into we will go into all these details. So that is why in the course curriculum, I mentioned the Snowpark. So in Snowpark, we will see the data pipelines, right? So we can run Python code. So that is why first of all we will learn SQL. Then we will learn Python. Then we will learn the Snowflake data warehouse, and then we will learn Snowpark. Right? I mean Spark and Snowpark. I mean the concepts are similar, right? So that is why we are first of all doing SQL, because in the you can also send the Snowpark. You can also work with Snowpark and Spark using SQL as well. So SQL is important even if you are dealing with the Spark databases. Okay. 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 Shall we start? All good? Are we all set? Do we? So we had all our tea or coffee, or are we all good? I need to hear your voices. Charan, Divya, Lokesh, Mahesh, Meyapan. Hi, Meyapan. Good morning. Hi, Sidhu. Hi, Rupali.
Good morning. We can go good to go.
Yes. Okay, great. So you had your cup of coffee?
Yes, had it tea.
Okay, great. Okay. Okay, so let's start. Okay. So yesterday we understood something called as databases and what the databases do, right? Now we have a lot of different type of databases out there in the market, and then based on what we want to store and what we want to do with that stored data we have to decide which type of database we want to use. Okay. Okay. So hi Miyapan, very good morning. Okay. So if we talk about databases, so there are different type of databases out there in the market. Okay, so yesterday we had discussed something called as RDBMS, which is a relational database management system. So let us first of all talk about each and every database we have. Okay, so this stands for relational sorry, relational database management system. Okay, so now let us understand each and every word. So now if we are working with the relational database management system, it means that this is a system. So it is a management system, so we will come from right to left. So it is a management system which is managing a database, right? So it is a management system which manages a database, and which type of database it manages is a relational database. Okay, so now we understand, okay, what is management? We have understood yesterday what is management, what all things we can do, and then we know what is a database. Now, we want to understand what is a relational database, right? So, relational databases are databases which store all the information in terms of tables. You can only store tables, and then those tables are going to have relationship among each other. Okay, so the data stored is in term of tables, term of tables, and those tables have relationship between them. Okay. So this is where you can understand what is the RDBMS. Now, we want to understand one more thing. What is a relationship? How are tables related to each other? How can we relate tables to each other? What is a relationship, right? So for that, we will understand what is a relationship. Between multiple tables, we could have some relationship called as referential key, Okay, so we will come into these things. Okay, so I'm just writing everything which we have to decide. So I'll go one by one into all these things. Okay, so we have multiple keys. So we have primary key, we have a secondary key, we have multiple constraints. So all these things, all these concepts come under the RDBMS. Okay, now why we use RDBMS? So let us also talk about the use case we have. Okay, so this is the generic description. And then if we talk about use case, then the RDBMSs are very good with storing the transactional data. If you want to write a lot of data to your database, then RDBMS is going to be a good choice for you. If we have, if we give, no, if we have a lot of data to write or update. Okay. So let's say I have some data. I want to write that data into a table, and the data which I'm writing or updating on those tables. So we talked about writing and updating. So I'm talking about inserts and deletes. Okay. You can also delete as well. Okay. So if you are manipulating your data a lot, then you need to go with RDBMS. Okay. So I'll mention one over here. Okay. And then let's talk about the second type of database. There could be like, this is not your requirement, right? So then we have some other type of databases. Other type of databases are data warehouses. Data warehouses. We also call them multiple parallel processing systems. Okay. So I mean, this is very rarely used, but we should know that there is another term for data warehouse. Now, data warehouses, as the name suggests, we have the warehouses everywhere, right? We have the Amazon has a warehouse, the Blinkit has a warehouse. So warehouse is a place where you keep some things stored so that it can be referred later on. So, for example, your Amazon will have some. They also use some terms like deep store, dark stores. So you can understand those to be warehouses. So there is going to be for example, Amazon warehouse where they will keep a lot of product which is usually in demand, so that when the requirement comes, they can get that data from there and then they can deliver it to the customers. Okay, so the data warehouses. So let us talk. Okay, I have. Sorry, I didn't hear. But what does it? Oh, this is a referential key. Sorry, Yarupali. I'll go into that detail. So when we talk about tables, right? Okay. So the data warehouses are here. Okay. So the use case for data. So one thing which you have to understand is that even in the data warehouse, there is a very similarity with the RDBMSs. Okay. So this thing is common. Okay. So in the data warehouses as well, the data is stored in terms of tables. And over there, we can also define relationship between those tables, right? So this is a similar thing which the RDBMSs and the data warehouse share. Okay. Now, on top of that, we also want to specifically focus on a use case for which these data warehouses are defined. Now, you have a lot of data, you have stored a lot of data in your database, for example, in your RDBMS. This RDBMS is going to have a lots of data being stored in the system. So now this system you will dedicatedly use to save your data, your old data. So because you will have a lot of data in your RDBMS, the data can grow really fast, right? Because if you have a lot of data every day, for example, 1,000 rows are coming, 10,000 rows are coming. I mean, that is also very less as compared to what we have these days. Over here, the RDBMS will grow very large with time, right? So the tables will become very huge because a lot of data is coming into the tables. So that is why we have segregated the necessary data on which we want to transform or on which we want to do the reporting. We will take that specific data from the RDBMS and then we will keep in the data warehouse. Okay. So the use case for data warehouse is that we want to perform analysis analysis on top of data. So now one thing we can very well see over here, for example, we were talking about ETL pipelines. So let us talk about a very small example. Let's say I have an application. You can think of this application to be, for example, your Amazon Web Services, right? Or your Amazon website where you go and you buy your stuff and all these things. Okay. Every application is going to have an RDBMS at the backend because every day thousands of people are coming to this application or these websites, and then they are purchasing stuff, they are adding stuff to their carts, they are doing a lot of things. So every day there could be thousands, hundreds of thousands of records which are which are being created, and we want to capture all those changes, right? So we will capture all those things, whether what someone is buying, where do we have to deliver it, whether the payment is done, what all different products a customer buys, what are added to the cart of a customer, and what all things you can think of. We are going to store all those information to an RDBMS, right? So you can think of, so this is how the flow works first thing. Okay, so this is how you are storing a lot of data which is coming in your database, which is an RDBMS. Okay, so the database is an RDBMS. Okay, now this RTPMS is expected to grow every day. Again, we have discussed. So, example, for 1 year, we are generating 100 GB of data, for example. Okay. Now, what will happen if we are aggregating a lot of data? The size of the RTPMS will increase a lot faster than we expect, right? So, this database, for example, if this RTPMS has data for 10 years, you can think of it that the size will be like 1000 GB. It will touch to around 1 TB. Okay. Now, what I want to do, I want to analyze some information from this database, but I do not want to do analysis on this 10 years data. I just want to analyze the information for the last 1 year only. I do not want all this information, right? So what I will do, I will use another type of database, which is a data warehouse. And what I will do, I will take only specific data from my RDBMS. So what I will do is that from its RDBMS, I will extract only 1 year data from there. Okay, so because I want to understand the pattern for 1 year, I do not want to have this 10 years data. So this is going to be your data warehouse, right? So this is one thing which we have also been discussing since our once first lecture. So if we come here over this place, so we were discussing about something called as E, T, and L. Now, so now think of that data warehouse. This is your extract. So you are extracting some data from RDBMS. So let me put it more down. So let me place it over here. And then if I do take it here. So now we discussed about extract. So because we do not want 10 years data, we just want just 1 year data. So we will extract the appropriate data from my RDBMS. And then I might need to transform the data. So for example, for my reporting, I need to create some additional columns. So we will talk about all these things in the future section. Yeah, so now we talked about this ETL pipeline. So now I will connect to the system. I will extract the that much data which I want. I might need to do some transformation or add new columns or define new joins. And then I will finally load that data into data warehouse so that I can do a reporting on top of that, right? So all the reports which we generate, those reports are generated on top of the data which is stored in your data warehouses. Okay. So this is how it is. Okay. So this is your most of the projects which you might have seen, which use very, very basic things. So this is the basic requirement of what is going on. Okay. So if you want to do any analysis on the data, then you have to use the data warehouse to select and persist that specific data into the data warehouse, right? Similarly, we also have a lot of different databases. For example, we have NoSQL database, which does not support SQL. So not going to those details. So, but there are databases. For example, there is Cassandra, there is HDBS, HDFS, sorry. So there are different databases which do not support SQL, right? And then if you want to store some graph data, we have graph databases. And then for example, if you want to have some other type of databases, if you have to have if you want to store your data for vector, Then we have vector databases. So now over here you can see that we have different type of databases. So we also call them purpose built databases. So whatever purpose you have, for their purpose you will use a specific type of database, right? Okay, so we have, I mean, there could be more type of databases. There could be NoSQL. So there are a lot of, okay. And yesterday we talked about RDBMSs. So RDBMSs, we talked about that we have something called as MySQL. We have Microsoft SQL Server. Um, we have Oracle. We have a lot of different databases. SAP HANA is there. All these are different RDBMS solutions. And then in the data warehouse, we have the Snowflake data warehouse. Sorry, Snowflake data warehouse. We have different data warehouse, like we also have Redshift, which we are going to talk about, and so on. So I mean, the list is very huge. Okay, so these are not the only options, right? So NoSQL, we have again Cassandra, and then GraphDB, we have GraphQL. For vector databases, we have a lot of very popular databases, but that is not for our discussion, right? Okay. Now, I want to discuss more about the RDBMSs. So, for understanding the RDBMSs, first of all, we need to understand the terms which we do not know so far. We have not discussed what is a table. We have not discussed what are the relationship between tables. Okay. So, let us talk about tables. So, what is table? Can someone tell me? Why do we actually need a table? What is a table?
Uh, Table basically where we store our data in row and column format.
Okay, great. Okay, okay, thank you. So over here, where is the table? Okay, so now this is how your table looks like. So your table represent an entity or a transaction, and it consists of something called as row, a column, and a data warehouse. Let us look at that in right now. Okay. Now, what I want to do is that let's say we have this session every day, and then I will have something I want to record, or I want to save the different details associated to a different session. So I will have the session ID, right? What was the identifier for a session? And then I want to see, oh, okay, 1 second. And then I want to see how many users joined, users underscore joined, right? I will keep the column name small. And how many users joined? What was the date of the session? And then what was the duration of the session? And then we will see what was the rating of this session. And then if people joined this session, if we had this YouTube video uploaded, and then we also see how many views on that video was. So I want to store all the things which are there for a specific session which we are conducting. We can also have more columns as well. Okay. For example, for example, the very first session we had, it was on Thursday. So I'll store it over here. It was on 27th of June. So 27th of June. And oh, sorry, the user joined, for example, there were 33 people who joined. Oh, sorry. Okay. So 33 people joined, for example, and it was on 27th of June. And then the duration, for example, was, for example, 2 hours. The rating was, I don't know, for example, let's keep it 4. And when we uploaded this video on YouTube, we had, for example, 300 views, right? And then second day we had another session. The number of users joined were, let's say, 27. Okay. And then the date for that was 28th of June. 28th of June. And then the, let's say, duration was 1.5 hours. And then the rating was 4 again. And when we uploaded it on YouTube, we got, let's say, for example, 224 views. Then we had session number 3, which was yesterday. So yesterday was 2nd of July. 2nd of July. And sorry, the user joined, sorry, it's the wrong column over here. And then the user joined, for example, it was 22. Okay. And then the duration was, for example, 1.2 hours, or I can also put it in minutes. The rating was, for example, 4.1, and on YouTube we got, for example, 150 views. And today, for example, today I can see that there are 14 users. So I will have to put it like this, and this one as 22. And then we are having this session today. So it is going to be the July of 3rd, and let's say, for example, it is going to be 1.1 hour long, and then the rating, I don't know. Okay, for now, I do not know these things. Okay, so now over here, we can see that this is some information which I want to store, and I have something called as tables in which I can store this information. So a table is a very well structured format in which I can store some information. I have the session IDs, I have the user joined, I have the date on which that session happened, the duration, the rating of the session, and the views which I got. Okay. So this is a one example of the tables. And then you can also think of very different type of table. For example, the very popular table, we have the employee table. So in the employee table, we can think of what all different attributes an entity has. Okay, so now let me also talk about the entities and attributes. Okay, so now we have something called as an entity. An entity is anything that exists in this world. Okay, any entity. Okay, a car is an entity. This laptop is an entity. This session is an entity. The table is an entity. Your chair is an entity. So entity is anything that exists in the world or in the universe right now. You can say universe is also an entity. Okay, so every entity is going to have some attributes. Okay, so attributes are properties associated to an entity. For example, if I take entity car, so then in the attributes, I will have to mention the different properties associated to a car, right? For example, I want to have the car details, or I want to store the information about different cars in the specific locality, right? So then what I will do, every car has different attributes like name of the car, the color of the car, the model of the car, the chassis number, it is going to have the chassis number, the engine number is going to be different, engine number, and then we have the model and so on. Okay, so every entity, for example, if I took about employee, an employee is going to have different attributes. What is the identifier of an employee, and then what is the name of an employee, what is the age, what is the address, and then what is the city where this employee lives or comes from, how far that person lives, what is the phone number of this employee, what is the joining date of this employee. Okay, and then now one question to all of you, if I have an entity called as, for example, a store or a supermarket, what all are the attributes associated to a store? So I have one more question. So we will talk about. So I want all of you to let me know, if I talk about a entity store, what all are the properties or the attributes associated to a store?
Location of the store,
Okay, great.
Branch manager,
Okay,
region,
great. So I can just write
uh,
manager.
employees,
Okay, great. Number of employees who work there. Awesome.
the
employee
size,
ID,
Sorry.
employee ID,
Okay. Employee
ID
ID.
of an
Yeah, I mean employees. Employee ID you can also have. That's fine. And
People store ID will
yeah.
also have.
Of course, we need store ID. So we will talk about ID, why we are actually having IDs everywhere. Okay.
We have
And
product ID, Vipul.
to see the
what
common
all products we
relationship
are
between
selling
the
there.
tables.
Right.
size
Okay.
of the
Sorry,
store,
sorry.
the size.
Size. Yeah. Yeah. So in how much square foot is the size of that store, right? Okay. That's great. We have got a lot of things. So over here, we are storing the different attributes associated to a entity store. And now can someone tell me what is the product? So I'll just write product ID. So we will talk about why ID is required anyhow. So now can someone tell me
Product
what
name,
are the
Product
different
description,
attributes?
product name,
Okay, great. Name, for example. Yeah.
the rate,
Okay, great.
description, rate, quantity, rate,
Quantity.
price,
Sorry, I'm missing it.
Price.
sales, sales,
Price is there. We have it. And
and you will have your GST or
say,
something that particular
right. Or we
taxation
can
part.
also say, yeah, exactly. So let's say if I'm also giving some discount on a specific product, I can also say discount, right? And I also want to say how much quantity I have. So now we all got the idea, right? So now we are all on the same page. So then what is the entity? Your entity is a table, and all these things which we have over here, the properties or the attributes of a table become columns. Okay. So now the store is a table. Entity name becomes a table name. So we can give any name to an entity. Okay. So I can say store, I can say store underscore name, I can say store underscore table, TBL underscore store. So that naming convention is something else. Okay. Then every entity of, sorry, every attribute of an entity becomes one column. So over here, we can see over here as well. So for example, if I am tracking the sessions, or I can say KSR KSR data analyst sessions. So this information is this one. Okay, so this is the table. The entity is a table, and then I have different attributes, and each attributes become one column. Okay, and so over here, for example, we talk about the products. Okay, so now uh, I will leave this product ID for now because that is something we will understand why we created that. Okay, so for example, we have something called as apple. That is a product. The description is that, for example, it is a red apple, and then the rate is, for example, it is 10 rupees per price. So I'm talking about the rate not in kilos but a unit price. Okay, for example, quantity is one. For one apple, it is 10 rupees. The red apple is this much. And I'm not giving any discount, for example. And then I could have an apple. I could have a golden apple as well. And then the rate is, for example, it is cheaper. And then the quantity is this one, and we are not giving any discount. And then we also have bananas. Oh, bananas. And then, of course, they can be in different color. We could have the ripe banana, or you could also have the raw banana. Okay, so we have different types. So banana is cheaper, five. For example, I just want to tell 30. Oh, the price right now is 60 rupees per dozen, right? So we don't have any discount. And then again, we have bananas. So raw bananas, they are, let's say, cheaper, for example. And this is how you can see that this is how the different details of different products are saved in the this becomes the instance. And then we have the different entities, and then this. So one instance becomes called as, we call it a row. Okay. Okay, that's great. So we now talk about tables. So we now know about the basic tables. So these tables, what we have discussed about, these tables are going to be in the RDBMSs. You are also going to see them in the data warehouses as well, because the data warehouses anyhow take the data from RDBMSs. So we are just taking the table, we are taking the data from RDBMSs into a data warehouse using tables. So that is why tables are here, tables are here. Okay. So in a sense, they are the same thing. Okay. Now, okay. So now, right now, we are talking about RDBMSs. RDBMSs are used for something called as OLTP. So can someone tell me what OLTP stands for?
Online
Online transaction
transaction.
processing.
Oh, that's great.
Online transaction processing.
Online transactional processing. Okay. Now, what is OLTP? OLTP is something where I am doing a lot of transactions. What are transaction? I am buying something, I am selling something, I am purchasing something, let's say I'm giving someone money. For example, on the Paytm, I give money to some of my friend, then it is a financial transaction. If I come to, let's say, if I buy some stores, if I buy some product from the nearby store, then it is also a transaction. It is a sales transaction, for example. Or there are a different types of transaction which we have. Okay. Now I just want to talk about one transaction. Okay. For example, I have something called as, there is a guy called as Ram. Ram went to ABC supermarket Oh, not supermarket, supermarket at 10 a.m. and bought 10 red apples. Red apples. Okay. I just also want to mention he went today. He went today at, for example, 7 a.m. Okay. So this is an example of a sales transaction. This is a transaction where some sale has happened. So this is a sales transaction. Okay. So this is going to be stored in the OLTP system. Whenever there is a transaction, whether someone is buying something, whether someone is sending something, whether someone is selling or purchasing, every type of things which you can say is can be boiled down to a transaction. Okay. Over here, can someone tell me to identify the different entities in this transaction?
Apple,
Huh?
red, different entities, right?
Right.
So all are different entities.
Okay. Okay. I
Except,
mean, can you tell me, I mean, who are all the entities who are making up this transaction?
The supermarket.
Right. For example, I will say the supermarket. Awesome. So I'll just say ABC. Okay.
Yeah.
I'm looking at it.
And,
Okay. Okay.
and,
And the apples.
okay, great. Ram is
And
also an entity,
Ram, yeah, name,
right?
purse,
Right. That's
price,
of course. Uh, price, no,
time
price is
also.
not right now. I mean, no, not right now. We are just
Okay.
finding out the entities, right? Not the attributes of
Time,
entities. Right. Time is
time.
also an entity. Great. Okay. So now here we can see that. So congratulations. We have just found out the different entities. So an entity is very important for a transaction. If I do not tell you who did the transaction or who bought these things, it will be incomplete. If I do not tell you when this specific transaction, it will be incomplete. Where this transaction happened, if I do not tell you, that will be incomplete. What happened as a part of this transaction, again, that will be incomplete. Okay. So now we have found of the different entities without which this transaction makes no sense, right? Now, what I want to do now, now an interesting part. So we have identified different entities. Now I want all of you to now help me to identify the different attributes associated to these entities. So what are the ABC supermarket attributes? We already had that. So we are going to have the different attributes of this supermarket, like the name of the supermarket. What is the name of the supermarket? And then we have, where is this store located? Who is the manager of this store? How many employees work over here? And then what are their employee ID, for example? And then what all products we sell here? And then we have the size of the supermarket. And then again, apples is going to have different attributes. So again, I'm just going to say the name is a attribute of this entity. We have the description. So I mean, we already had that. So now just talking about the rate of this product, and then the quantity of this thing, and then we have the discount. Okay. So now, and we can also have multiple columns for that. We will talk about in a moment. And then if I talk about RAM, what are the different entities associated to the RAM? So there is going to be name. RAM has a name. RAM has an age. He has a gender, for example, associated. He also has an address associated where he lives. He is also going to have a phone number. He is going to also have an email address. Okay. So, and then if we come to time, so time has different attributes like what is the value of the hour, what is the value of minute, what is the value of the seconds, and so on, and what is the date as well. Okay. Okay. Now, every entity which we have discussed, every entity becomes a table and every attributes becomes a column. So now let's do one thing. Let us create tables out of these entities. So very first table which I want to create is going to, I just want to name it as a supermarket table. Supermarket table. Okay. And the second table which I want to create is going to be generalized because I want to talk about other products as well. So instead of apples, I will say I am talking about the products in general term. Okay. So I will create a product table. And then after that, I am saying I am not just talking about RAM. So I generally want to talk about this entity. This entity, I can say the customer, right? And then finally, we have something called as time. So we will have the time dimension. We can also have different dimensions like the location dimension, blah, blah, blah. But this time we just want to go very basic. Okay. Now, every column, every attribute which we have understood so far or we have extracted so far, every attribute is going to become a column. For example, name of the supermarket, who is the manager of the supermarket, and then what is the location of the supermarket, which city it is in, or which country it is in, or I can also say which brand it is associated to. There could be a supermarket which belongs to Reliance stores. So, for example, if the supermarket is a Reliance store, it belongs to Reliance supermarket. If there are Chroma, if you have a Chroma supermarket, that Chroma supermarket belongs to Tata. So, this is what I want to mention over here. I also want to note how many employees work here. What is the size of this supermarket, right? So, now we have created a table, and this table is going to have these columns, and these columns define or specify a specific attribute, right? Cannot we have timestamp and customer tables instead of creating time entities? Yes, that is possible, but then so the problem is we have a question from Meyapan. He's saying that cannot we have a timestamp in the customer table instead of creating time entities? The problem over here is that there could be multiple tables where I might want to have the time information. So instead of creating the timestamp column in each and every different entities, I will just link it to my time dimension, right? So I will have a specific place where I will have all the time specific information, and I want to segregate this from the specific entities, right? And then if we go talk about product, and then we will say what is the product name, what is the, so I can say the name of the product, what is the color of the product. We have seen the one product like mangoes. If you say mangoes can have different colors, we have yellow mangoes which are ready to eat, and then we have green mangoes as well, which are ripe and they have different purposes. For that we can have pickle for that. Okay. And then we can also have different we can say price per unit is also one thing. And then we are also going to have, for example, uh, we can have the brand associated again. We could have multiple brands. For example, if you go out and buy a multi-grain bread, you could have 5 different brands who are selling multi-grains, right? So this is one thing. And then again, I mean, we can go on and we can define multiple attributes associated to this entity. Then I just want space because I might need to create a lot of details. So if I talk about customer, I am going to have a name of the customer. What is the age of a customer? So all these things which we have just captured, we name, age, gender, address. So all these things I want to capture. Gender, the address, the email ID. Okay. And then we can also have the phone number, for example. Okay. Now, if I come to time, the time is again going to be a different entity. For this entity, we have different attributes. So what is the value of hour? What is the value of minute? What is the value of second? Which month I am talking about? Which quarter I am in? Which year I'm in. So all these things I just want to capture into my time dimension. So I'm all set and I have defined multiple tables. Okay. So these tables we are going to see in the databases and in the data warehouses. Now let us fill these details, right? So what we can see over here. So we have a supermarket called as ABC. For example, manager of this ABC supermarket is, for example, Sham. I am not getting very creative names. Okay. So if I say talk about a location, for example, this ABC supermarket is in, for example, Las Vegas. We can have this in over here. The country is USA. The brand of this, I don't know. Can someone tell me any big supermarket chain in the USA? Or I'll change the country if, if I do not get anything.
Kroger.
Sorry.
Kroger.
Can you spell it? Sorry.
Kroger.
Okay, great. Thank you. So now let's imagine that this is a medium-sized supermarket, and over here, 15 people work. And size of it, I don't know, I will say 5,000 square foot. Okay, so all these things, information are going to be stored. Similarly, there could be another supermarket, DEF, and the manager could be Hari, I don't know. And then this is again in Las Vegas. Las Vegas. Oh, sorry. This is again in Las Vegas. It is in USA. The brand is something else. I don't know. Some other brand could be there, or there could not be a brand associated to it, right? So number of employee work here is more, and it is a relatively larger store. Okay. And for example, let us talk about product. We could have different products. We have specifically said that we could have the apple, we could have red apples. The price per unit is, for example, 10 rupees, and the brand associated to is the Himachal apples, for example. Very good product. Similarly, we could also have apple, which are golden in color. The price per unit is, for example, they are cheaper and they belong to the same brand. If we come to the customer, we have a customer Ram right now. For example, his age is 22. He's a male, and his address is house number 123. And his email ID, I'm just making up. So, ram@gmail.com, gmail.com, and his phone number is 123456. Okay, whatever phone number. Okay, we are not concerned about the actualities of the data. And then if I talk about time, there are different things which I can also store in hours. For example, I have the time like 7 a.m. So 7:00:00. Month is, for example, July. The quarter, this is second quarter going on. The year is 2000 and, oh, sorry, 2024. I forget which year is going on. And similarly, we have another entity. For example, we are talking about 7 o'clock 1 minute. Then again, we are having the other attributes similarly. Okay, 2024. Okay. Now, this is a very good progress. So now we have created tables. We have inserted some data. So this is a data associated to a table. So a table is like a set of different records or different entities. So this is one record. We call the rows as records. So we call this as a row. So these vertical things are your rows. Sorry, why is my rows? Okay. So rows, or we also have multiple names for that, but right now we will stick to rows. Okay. And then this is first column, this is second column, third column, fourth column, and your product, which was an entity, it became a table, and each attribute became a column. Okay. Now, over here, there is one problem. Let us look at the different problem and overcome one by one. Right now, I just am not able to identify the supermarket on its own. I have two stores in the same location, in the same country, and for example, let's say they belong to the same brand, right? So it is very difficult for me to identify a supermarket uniquely. If I talk about the Kroger brand, I am standing in this specific area in the Las Vegas, and then I am asking where is the Kroger supermarket. Then that person will ask me which Kroger supermarket you are talking about. Are you talking about the ABC supermarket, or you're talking about the DEF supermarket? So that is why whenever we create a table, we need a special column which will help us to uniquely identify each and every row. Okay, so that specific column is usually called as identifier column or the ID column, which will have unique values to identify each and every different you can say instance. Okay, so we talked about this one row is going to be one instance of an entity. So this is instance number one. This is instance number two. Similarly, for the products, I need something called as the product ID, which will give unique number to each and every instance or to unique number to each and every row associated. So this is product ID 1, this is product ID 2. One thing which I want to clarify over here, we do not necessarily have to have the identifier as numbers only. We can also create something like this P001 and P002. Okay, so there is no hard and fast rule to have the identifiers as numbers. We can also have them as the alphanumeric as well. Okay, and then if I want to customers, then over here in this table, I also need a customer ID, right? And then, for example, customer ID of Ram is C0001. And then if I talk about time, we can also create the time ID. So this time ID is again going to help me the different instances. So for example, this is 1, this is 2. Okay. Now, very successfully, we have created multiple tables and then we have defined the different things, right? Now, what I want to do is that I now, for example, want to define this transaction. We have identified the entities, we have defined their attributes, we have created tables, we have populated those tables with the data. Now, I I still am lacking something. I am still not having a place where can store these different transactions. I do not have a table where the data from these multiple tables are related or associated to each other, right? So right now, the tables where we are looking at, those tables are dimension tables. Okay, dimension tables. So the dimension table are the table which provide us information about a specific entity only and nothing apart from that. So this becomes your first entity. So this is your supermarket dimension. This becomes your product dimension. This becomes your customer dimension, and this becomes your time dimension. So dimension is synonym with anything we say. Okay. So when we have a entity and for that entity we create a table, we can also say it to be a dimension table. Okay. Now there are some special type of table which are called as fact table. So these fact tables are also tables, but these tables represent a transactional detail. Okay. So whereas the dimension tables represent these tables represent the entity, whereas I have something called as fact tables. These fact tables represent a transaction. Okay. For example, and let's talk about this. Okay. Now, if we go ahead, we are going to need a fact table so that we can join the different dimension tables together. So let's, for example, take a fact table. Some additional thing which we want to understand about the fact table and dimension table is the dimension table can have any data type. Okay, let's go one step back and let us talk about the data types. Okay. Okay. So now when we discussed about the entity and each entity has attributes, each attribute has something called as data type associated to it. So the data type helps the database or data warehouse to know what type of information you are going to store in that specific attribute. For example, the names are string, right? So we are going to have names like alphabets, and we are usually do not have the numbers in our name. For example, we are not kids of Elon Musk, so we are going to have proper names, right? Not taking that extreme example. So here you can see that we are going to store string information in the name. The color is again a string. Uh, what is the model of a car? So this is a car. So then the model is again a string information, not a string, but a string. And then the chassis number could be alphanumeric. It could be number, it could be alphanumeric as well. For example, the engine number is a number. And then we have a model name. I mean, I don't know why I mentioned this model again. So over here, we can see that each attribute is going to have a data type associated to it. The dimension tables can have any data type. So over here, we can see that if we look out at the supermarket dimension, the supermarket dimension, the attributes. So this is the very first attribute. This is going to have the numeric information. The number of employee has the information for the numbers. This also is number. So we have different type of data types in a dimension tables. Whereas if we talk about fact tables can only have numerical information, can only store numbers. Okay, we cannot have string information in the fact table. Over here, when I am talking about a transaction, let's see what all details I need to store in my fact. First of all, I need to understand who customer did the transaction, in which store he went, what was the product which was sold as a part of this transaction, and then what was the quantity sold, And then I just also want to see what was the total sale amount and what was the discount, for example, what was the GST as a part of that transaction, how much profit was made as a part of this transaction, and who did the transaction. For example, I also want to have another column for an employee ID, okay, or the employee who actually was working at the desk or who was working at a specific store when the transaction happened. Because whenever you go to a supermarket, there is a person who is going to do a billing for you, so this is a person who is going to do billing. Okay. So over here, instead of the names, because in fact table I can only have numbers. So from here I will take the ID column. Okay. What I will do, instead of specifying the name of the person, Ram or Sham, for example, I didn't mention Ram anywhere because, oh, this is a supermarket, sorry. So I just have to first of all come to the customer. Okay. So instead of saying Ram over here, I will have to say C001. Time ID is not needed here, right? Where? Here, right? Yeah, we can also have the time ID, right? The time at which the transaction happened. Thank you. Okay. So I mean, we can have a lot of columns. Instead of employee ID, I will say Ram. Okay. Time. Okay, so I just want to also want to capture when this specific transaction happened. Thank you. Okay, so now over here, because I cannot have names, I can only have numbers. For example, this is one. I will just keep everything simple over here. Okay, one, two. Okay, oops. Now, over here, I will say who came to the store. Ram came to the store, but I cannot have string information, so I will say customer ID 1 came to the store. Which store he came? He came to ABC supermarket, so store ID is 1. Which product this guy bought from the supermarket? Product Apple. What is the product ID? A product ID 1. And then how much quantity that guy purchased? So he purchased 10 red apples. So quantity is 10. What was the sale amount? Because, for example, each red apple is worth rupees 10 and he bought 10 red apples. So the total sale was 100 rupees. And was there any discount provided? Let's say there was 1% discount which was provided to him, and 1% is 10 rupees. And then GST, let's say there is no GST on this. So, for example, we can say we can leave it as blank. And then, oh, sorry, what was this? What was the this is like the price, and this is now we can say that sale amount. Okay, and then because there are 1% discount, so the transaction was for 90 rupees, and because it happened at 10 a.m., so we'll also mention because we oh, it happened at 7 a.m., right? Yeah, it happened at 7 a.m., so we will say this time identifier 1. Okay, now this is a fact table. So if you look over here, this is a numerical or tabular representation of this sales transaction. Whatever information, if I give it to someone this line, or if I give them these tables, anyone can understand what is going on. One thing, what we have done, these ID columns are an identifier for a table and they are called as primary keys. So the primary key is a key which is a key for a table which help us to uniquely identify each and every row or each and every instance of an entity. Similarly, this is again a product ID. This product ID is the primary key, and this is customer ID is the primary key. And similarly, we have this primary key as well. Now, what we are doing, we are actually storing the data over here and we are referring to this data, the dimension data from the fact tables. This customer ID 1 is not stored in this table, it is coming from this table. So that is why in the fact table, we have something called as referential key. So what referential key says is that this information is not existing in this table, but it is coming from another table. I cannot have value for this is not possible. I cannot have customer ID 3 because customer ID 3 is not in this table. So we will talk about this all these concept when we go into the databases, but still I just wanted to have a background of all these things. So when we have a referential key, the fresh referential key is referring to this table, to this specific column of this table, and we cannot have any value outside of this 1 and 2. So I can have ID 1 or 2. Similarly for store, I cannot have a store ID where it is. Oh, sorry. This is the store. Sorry, I go for customers on the above table. Okay. So the customer ID, I can have only customer ID one. I do not even have a customer ID two. I cannot even give two over here. Okay. So the values over here in the referentiality columns are going to come from a primary key only. Okay. So what I can do is that I can draw these arrows. I can say that this customer ID is coming from this ID. And similarly, this store ID is coming from, where is the store? Oh, sorry. This is the customer. Oh, sorry. My bad. So let me do it again. So now, first of all, I just want to mention where this customer ID is coming from. This is coming from here. And then we have something called a store. This is your store. Where is the store table? So we have the supermarket table. It is coming from here. Similarly, we have the product ID. It is coming from here. And then we have the quantity price. It is not coming from any table. Then this time is coming from it. Okay. So this is your RDBMS. In the RDBMS, everything is stored in terms of table, and then we can define relationship between multiple tables. Over here, we have seen primary key and foreign key relationship between the dimension table and the fact table. Right now, before moving ahead, this is your OLTP. Okay, so these tables give us your OLTP. These are your transactional information, right? So this is your transaction. So using this table, you are storing OLTP. So now you are saving different transaction. If I give someone these tables, they can understand what all different transaction happened. Okay. Now, for example, there is also one concept called as AOLAP. I mean, first of all, let us look at over here. So, okay, so we had different entities. We created the attributes, and then for each attributes we created a column, and then we filled that table with some data, and then we created a fact table and then linked it back to the that dimension table. But what is the use of this table? Why are we even bothering about this? Because see, we are only referring the data. Why I do have to do all this stuff? Let's talk about why we need a fact table over here. So if I give you this table, and then if I give you multiple details, for example, if I just copy the multiple details over here. So for example, if we have multiple customers like customer ID 222, 3, and then there is multiple stores. So for store ID 2, we have different products. For example, 2 over here, different quantities was sold, 7, 7, 8, 6, 5, 3. And then we have different prices, for example, 100, 70, 60, 40, and then different discounts. Okay. And the different sale mode. 100, 30. So there were different sales which happened. So a customer or multiple customer came to the supermarket and did some transaction. This is, for example, your, again, we can also have a key to this. So for example, this is the very first transaction. So Ram came to store, he bought 10 red apples. Then another customer, for example, we have another customer over here who is, uh, uh, I don't know, Farha. So Farha came to supermarket. Her age is 17. She's a female and she lives in this house. Okay. And then we say that Farha also came to the supermarket and bought some product. Again, Farha came to the supermarket at different times. You can say that different time IDs. Okay. So I can say different time IDs are there. So again, here you can see that Ram came to the supermarket. Again, he also did some transaction. So at different time, a customer is coming. From this fact table, I can do something called as OLAP. Can someone tell me what is the full form of OLAP? Online?
That is analytical
On
processing.
online analytical process.
Sorry?
Online analytical processing.
Yes, yes.
Online analytical processing.
Right. Great, great, great.
It will analyze
Uh,
the data of it.
oh, sorry. Huh?
It will analyze the
Yes.
data of a customer.
So now let me ask you some question. Okay. So as in OLAP, what we do is that we do some analysis. For example, there are different questions which I have. How many users visited the supermarket or the ABC supermarket? Supermarket. Uh, how much sale was generated? How much sales? How much sales was generated? Generated today in ABC supermarket. I mean, I can also ask question about different supermarket. Supermarket. And then I can also ask different question. Which customer uh, bought a visit is, or what I can say, which customer visits the ABC supermarket market the most? And then I could have different question as well. What is the time when the supermarket, ABC supermarket has a huge rush? I'll have to say huge rush. Okay. So what is the time when the many customer comes, and what is the time when very less number of customer comes? Which customer come how many time? Which customer goes to how many stores? What are all the different products as customer is buying? I can answer all these questions from this table, right? So this is what we are going to understand as a data analyst. You will have a table, you will have different set of tables, you will have different relationships between table, or you might have to create that. And then finally you will have a table or a set of tables. You can also do this analysis on top of your dimension table as well, right? For example, if you want to see, oh sorry, from the customer table as well, if you want to see what is the maximum age of a customer, who is the oldest customer who is coming to the supermarket, which is the costliest product in the supermarket which we are selling, which supermarket is having the largest size, which is the supermarket which is having the smaller size, which how many supermarkets are there in a country. So all this information we can get from this table, and that is why understanding the OLTP and OLAP is very, very important for us. OLAP, this is OLTP. Whenever we have a transaction and we store that transactional information in the tables, that is OLTP. But when we are trying to answer a question, when we have a scenario and we find out what is going on at the back end, then we are doing OLAP. So one thing, so your RDBMSs are good for OLTP, whereas your data warehouses are optimized for your OLAP. In your data warehouses, you will be analyzing the data. So that is why these data warehouses are optimized, or they are created for doing the analysis faster, to answer your queries faster. Whereas your RDBMSs are OLTP, and these databases are designed to have faster transaction, to store data very fast, to update data very fast, to insert data very fast, or to delete data very fast. So that is why we call these different type of databases the purpose-built databases. Okay. So now, whatever purpose you have, you will have to choose a specific database or a data warehouse. Okay. So that is it for today. Any questions? So are we all good? Are we on the same page? So tomorrow we will actually install MySQL in our system, and then we will see all these things practically. How to create a table. We will also see creating a table, creating columns, adding new rows, and all these things we will see one by one. Okay then. Thank you so much.